All right, let's get into it. Today, we're talking about a discovery that basically takes the quantum mechanics rulebook and tears it right up. We're looking at a brand new phase of matter, something that just shouldn't exist, called the unbreakable quantum liquid.
You know that one sentence? It pretty much sums up a whole revolution in physics. For as long as anyone can remember, the quantum world was thought of as this incredibly fragile, delicate thing. Well, we're about to see how that core idea just got completely blown out of the water.
So, to really get why this is such a huge deal, we've got to go back and understand the old way of thinking, what we can call the quantum fragility myth.
I want you to picture a soap bubble, or maybe a super intricate sculpture made of spun glass. That's honestly how physicists used to think about quantum states. The tiniest little disturbance, a stray particle, a slight shift in temperature, really any contact with the outside world, and poof, it's gone. The whole quantum effect just vanishes.
And when I say delicate, I'm not kidding. To keep a quantum state alive, you needed the most extreme, pristine conditions you can possibly imagine. We're talking temperatures colder than the deepest parts of space, vacuums emptier than the void, and massive magnetic shields to block out, well, everything. This wasn't just a challenge for scientists. It was seen as a fundamental wall stopping us from building any real practical quantum technology.
So this chart really lays out the conflict perfectly. On one side, you have the old myth. Everything is fragile, delicate, needs to be kept in a bubble. And on the other, this new reality, which is the exact opposite. It's tough, it's resilient, and it's totally ready for the messy, real world. This is the setup for the big breakthrough.
And that brings us to the discovery itself, a new kind of quantum matter that isn't just a little bit tougher than we expected, it's, for all practical purposes, indestructible.
Now, this didn't happen slowly. This was like a lightning strike. For decades, every experiment just kept confirming the idea that quantum stuff was fragile. Then, in 2025, a paper drops from researchers at UC Irvine, and it changes everything overnight. The rules that we thought were written in stone? Yeah, they're being torn up and rewritten as we speak.
So what exactly did they find? They stumbled upon something called an excitonic liquid. In the simplest terms, it's a quantum fluid made of these little things called excitons. Now, think of an exciton as a little team-up. You have an electron and the empty spot, or hole it left behind, and they act together like a single particle. They found this crazy new state in a special material called hafnium pentatelluride, and it can do things we literally thought were impossible.
Which brings us to its most mind-blowing property. They hit this material with everything they had, gamma rays, X-rays, the whole shebang, and the amount of damage to its special quantum state was zero. Nothing. Zilch. This is the first quantum material ever discovered that is effectively immune to radiation.
So you have to be asking, how is that even possible? How can a quantum state, of all things, be so incredibly tough? Well, the answer lies in what the researchers are calling the 4 pillars of its strength.
Okay, so these 4 pillars, pairing, condensation, resilience, and functionality, they all work together to make this stuff so incredible. Let's build this thing up one pillar at a time and see how it works.
It all kicks off with pairing. The electron-hole pairs in this material form a really unique buddy system. They're what scientists call spin-triplet excitons, which just means their magnetic spins are aligned in parallel, kind of like a bunch of tiny magnets all pointing in the same direction. And this specific setup, it turns out, is the first secret to its power.
So next up, condensation. These little pairs don't just drift around on their own. Nope. They pack together so tightly that they actually form a macroscopic quantum fluid. It's a liquid that moves and behaves like one single unified thing. It's less like a gas of individual particles and more like a perfectly choreographed mosh pit where every single person is moving in perfect sync.
And right here, this is the heart of it all, resilience. This quantum liquid isn't just strong in a passive way, it's an active system. When it gets hit with something that should damage it, it has this incredible, almost instantaneous ability to repair itself. This is the magic trick that makes it radiation-proof.
This self-healing ability comes from 3 really clever physics tricks working together. First, its quantum state is all spread out so it can't get pinned down by a single little flaw in the material. Second, the excitons bounce around and interact so fast that they can fix any temporary damage almost instantly. And third, remember that special spin-triplet state? Well, that arrangement actually prevents chemical reactions that would create new defects in the first place. It's a true trifecta of toughness.
And the final pillar is functionality. I mean, this stuff isn't just some weird lab curiosity.
it actually does things. For one, it glows. It gives off this really bright, high-frequency UV light. Plus, it can store energy. You can pump it full of light, and it holds on to that energy in its quantum state for a long time, basically acting like a tiny, rechargeable quantum battery.
So what's the big picture here? What does all this mean? Well, it means that the future we've all been dreaming about for quantum tech, it just got a whole lot closer and honestly a whole lot cooler.
Look, a material this tough isn't just an upgrade. It's a gateway. It throws open the door to all sorts of applications that, until now, have been pure science fiction. Let's just run through a few of them.
Okay, first up, think about satellites or probes we send to Mars or Jupiter. Imagine building sensors and electronics for them that can just shrug off the intense radiation of deep space without needing all that heavy, bulky shielding. This material could make that happen.
And because it's so good at storing energy and information in its quantum state, it's a killer candidate for new kinds of memory. We're talking about super low power, long-lasting quantum memories that are almost impossible to accidentally erase.
Now this is the big one. The single greatest enemy of quantum computing is something called decoherence. That's just the environment messing with and destroying the fragile quantum state. A material that is literally immune to that kind of interference, that could be the bedrock for a new generation of quantum processors that actually work in the real world.
And hey, remember how it glows? That bright, high-frequency light could be harnessed to create incredibly powerful and focused light sources, perfect for beaming data across the insane distances of our solar system or maybe even beyond.
When you boil it all down, this is the core takeaway. This discovery proves that the quantum world, which we all thought was so delicate, can actually be incredibly tough. It shows us that these amazing quantum effects don't have to be locked away in a perfect lab. They can exist and even thrive out here in the real, messy, hostile world.
And that just leaves us with this one absolutely fascinating question to chew on. If a material this game-changing was hiding in plain sight, completely upending decades of physics, well, it just makes you wonder, doesn't it? What other fundamental rules are just waiting to be broken? What other so-called impossible materials are out there just waiting for us to find them?